Okay, they finished their announcements, and I'm not making a new video. I'm sorry. This is far from perfect, so we're going to just deal with what we have. Okay, so the next one, how many permutations end in C? I went ahead and showed you this, the answer from the back of the book, or in the book. What we would do is we would say, well, this slot right here has to be C, so there's only one choice. So that means that the four other things, you've got four choices for the first one now, and three, etc. So, so that's how you would get, there's one choice for this last spot times 4 factorial. And then they say, how many permutations have the form blank A, blank B, blank? Well, so same idea here. They filled in these because those are already decided for you. One of them was an A, the other one was a B. And then you have 3 choices for the first one, now 2 choices for the second one, and 1 choice for the last. How many permutations begin and end with a vowel? Begin and end. Okay, so notice you've got 2 choices here because the first one could either be an A or an E. But once that's decided, then you've only got 1 choice for the last one. And then the 3 other things can happen in the middle. That was a good little problem. Okay. Oh, I like this one. There's 6 books arranged on a shelf. How many way can 2 of the books A and B be together? So we definitely have seen one over the years where they say you've got you've got math books, English books, and a dictionary, and I forget. I'll see if I can find that problem for you. But basically, A and B, I would draw that out that there's 6. Well, A and B can go in like these two, or these 2, and these 2 to be next to each other. But it can either be A, B, or it could be B, A. And so that's how we figure out where those are going to go. But then the other 4 books, so it's, you have, what is this? I guess they said 10 of these. So you've got 10 choices for where you're going to put A and B on the shelf. And then it's each one of those then has 4, you have 4 choices for this, 3, 2, and then 1. And so that's where they get that number. The bell's going to ring soon. So, okay, now we get into, let's see. How many different teams of 3 can be selected from a squad of 8? Okay, now different teams of 3 tell me that it doesn't matter what order I pick them in. So now we're looking at a combination. And a combination, hopefully we have talked about it in other videos. That formula is n factorial over n minus r factorial. How many different teams of 3? Okay, so we're doing 8 choose 3. If there are no restrictions, it's just 8 choose 3. So 8 factorial over 5 factorial 3 factorial, which is 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2. Well, times 1 technically, but I wrote it out like this so that and that can cancel, and 3 times 2 is 6. So the answer to that first one is 56. Now, if the team must include the captain, now we have the captain, and then we have 2 other players. Let's just say 2 more. And then we would multiply those. Okay, so now the captain, sometimes they'll say like, say you've got 5 captains on a team. I don't know what team, but you have to have one of them. So then it would be 5 choose 1, and then you'd have other people to consider for. But in this case, this is just 1 choose 1. And then there's 7 non-captains in this scenario, right? Well, they don't imply that there's more than 1 captain. So we need to choose 2 of those. So then this becomes, 1 choose 1 is just 1. And then 7 choose 2, this is 7 factorial over 5 factorial, 2 factorial. I'm sorry, I'm going fast. The bell is going to ring. This is 7 times 6 over 2. That's 21. Okay. An equestrian team of 4 is chosen from 7 male and 6 female riders. How many different teams can be chosen if there's no restriction? So there's a total. So A, we would just say there's 13 people. We're choosing 4. B, if there's 2 riders of each sex, then it's going to be 7 choose 2 times 6 choose 2. And at least 1 rider. Okay, so with this one, now you could say we could have 1 male and 3 female. Or we could have 2 and 2. Or plus we could have 3 male and 1 female. Okay, so then this is 1 male, there's 7 choose 1 times 3 female, 6 choose 3 plus 7 choose 2 times 6 choose 2. I guess I don't have to write that dot in the middle. 3 male was 7 choose 3 times 6 choose 1. So we'd grab a calculator and figure all that out. And the bell didn't ring yet. I got lucky. Let me know if you have any questions. Go practice.